Yes. Uh, Good morning, students. The next topic, what we are going to see is conformal mapping. So, conformal mapping, we are going to see now. Step by step, we'll go. Conformal mapping. It will be really interesting. Actually speaking, this conformal mapping is a mere application of your chapter, what we study in this. In analytic function, what we are going to see is its application. Conformal mapping, as I said, it's a mere application only. Okay, I'll go for conformal mapping. Before that, we must know what is mapping. Already I have given you here. What is mapping we'll see, and then we'll go for conformal mapping. Okay, for that, before itself I have drawn you the graph, Z plane, W plane over here, because without graph we can't explain anything for you. That's why. So Z plane, W plane I have given you. Now, first of all, what is mapping? And then we'll see what do you mean by conformal mapping. Yes, initially mapping. So mapping means note down to each point, x comma y. As I already repeatedly I'm saying x comma y, nothing but values representing in Z plane. Similarly, u comma v represents the points in W plane. Both are complex plane only. Yes. Okay. To each point x comma y in the Z plane, the function f of z determines. As usual, from this plane to this plane, what is the function we have to define here? Function f transforms from z plane to w plane, which is nothing but function of z. That is w is equal to function of z. This is a function which transforms from z plane to w plane. Okay. Now, the function w equal to f of z determines a point u comma v in the w plane. So, which means for each point x comma y in z plane, will get a corresponding point u comma v in your w plane. So here x comma y, here u comma v. Say for example, here you have one point x1 y1. Correspondingly, here you will have one point. I mean x1 y1 here. If you define correspondingly here also you will have one point u1 p1. So suppose here x2. Suppose here maybe in second quadrant. X2 y2 means correspondingly here you will have what is that, u3 comma v3. I mean the pair of points exist, the process goes on. So this is nothing but mapping. Okay, similarly if the z point, the point z moves along some curve in the z plane, the corresponding point w will move along a curve in the w plane also. Say for example, so in the z plane you are defining this graph. The curve moves from this to from this position to this position. Similarly, here also the curve moves from one point to other point according to the point how we have defined. As an example, I'm giving here. If the curve transforms, I mean travels like this, here also the curve travels like this. So that is nothing but mapping. So it is nothing but for each and every point in the z plane. This is the thing. For each and every point in the z plane, corresponding curve or corresponding point exists in the w plane. This is said to be mapping. Okay, so mapping is over. When to say this mapping is conformal mapping? I'll explain now. When to say this mapping is conformal? So actually speaking, this f of z, we used to call this as transformation. So always remember, this is z plane, w plane. So intermediate, I mean in between that what we have here. So transformation function. Based on this transformation only, we have certain definitions. I'll explain one by one. So the second definition is conformal. So called the function f of z is nothing but the transformation. Now, a transformation, I mean the function f of z that preserves angle between every pair of curves through a point, both in magnitude and sense, is said to be conformal at that point. Yes, as I said, as mapping, as everyone knows, the curve moves like this. Here also the curves moves like this. So when to say this graph is conformal, it should satisfy both in magnitude. Magnitude means for each and every point x2, y2. Just now I have shown you. So x2, y2, x3, y3, x4, y4, all the points it should travel. It should satisfy. So each sense and magnitude it should satisfy. So here x2, y2 means here also u2, p2. It should satisfy. So magnitude also represents same as well as the direction. So however the direction it moves here, same direction, same sense it should maintain over here. If it maintains both in direction and magnitude, we used to call such a mapping as conformal mapping. Okay, can I go to the other definition? You are all clear in this? Yes or no? Once again, I'll say conformal mapping we are seeing here. Mapping means which is nothing but a function should be there. Through this function only we are going to find the image. So whatever may be the points you are defining here, the corresponding point will exist here. In the other way, I'll say whatever may be the object you are defining in the z plane, we are going to see in practical mode. I'm saying, listen carefully, whatever may be the graph, in the sense it is nothing but the object. Whatever you are giving some object or a graph in your z plane, we are going to see the image of this object in the w plane. So how to find the image? Without mirror we can't find the image. Just like that, without this transformation we can't find the image of this object. It is that thing. Okay, so try to understand this definition in a clear way, so that problem is very simple and easy. I'll do it for you. Before that, try to understand the mapping. So mapping, as I said, so we are giving some object here like circle, whatever you want, circle, triangle, square, whatever maybe the graph you want to test here, you just replace, you just represent in the z plane, give some transformation with the mirror we can't do anything, right? Just like that, some function is existing here, f of z. Through this function f of z, what we do, we are finding the image of this object in which plane? W plane. So that is the thing we are dealing here. Okay or not? So say for example, in z plane, this is w plane. Here you are having a circle. We are defining, I'm defining an object circle. Okay, what is my transformation? I mean mapping. So a function, I don't know, function f of z is equal to z square or z cube, whatever may be the function, I don't know. Through this function, what I'm finding here, image of this object may be like this. Okay, this is a thing we are going to see in this session. Okay, yes, conformal mapping. Okay, mapping, I said. When to say this graph is conformal, so this graph, actually we are going to find the object, image of this object only in W plane. That is the actual definition for mapping. Actually speaking, we are finding only that. But before going to that, f of z maybe anything. It is nothing but the transformation. Based on this, we have certain definitions. We are going to see step by step. Okay, conformal in the sense it should maintain direction as well as the point. Magnitude means what? That point as well as the direction also. Each and every pair here also it should maintain. Here if you have some direction, here also it should maintain the direction. Here if you have certain direction and sense, here also it should maintain. Each and every point it should maintain. Then only we say that mapping is conformal mapping. Okay, so conformal mapping is over. Okay, so next one, conformal mapping. After conformal mapping, we have one more definition, so called magnification. So magnification, what do you mean by magnification? I say, so now you're all clear in this transformation, isn't it? Transformation, as I said. Now, in particular, the transformation, what you take in your hand, I mean the mirror. The only through a mirror we are seeing every object which it reflects, or which some other object we are getting. So I'm taking this W as A times Z, where A is a real constant. Where A is a real constant. If you use this observation, I mean if you use this, not observation, sorry, if you use this transformation W equal to A Z, we will get the corresponding image. Whatever you are giving in your input, through this transformation, I'll get my output. Whenever you use this transformation, we used to call that equation, as magnification. That's all. Okay. So say for example, take A as 2 times of Z. Take A as 2 times of Z. In the other way, I'll clear you. Now tell me what is W in terms of your pair. Whenever in W plane, how will represent? W you will represent in terms of U plus IV equal to A times, let me explain the transformation. So Z is equal to X plus IY, which is equal to AX plus I into A into Y. Come on, tell me U is equal to AX and V is equal to A times Y. Okay. Now I think you're all clear here, right? What will be the point in Z plane and W plane? This is your Z plane. and this is your W plane. So what are all the points in Z plane? Of course, x comma y only know Z plane. What will be? So x comma y. Yes. What will be the point in Z plane then? Come on. Ax comma ay. Now you can add the points. 1 comma 1. Suppose a is equal to 2 times if you take 2x comma 2y. I mean 2 comma 2. Say for example x comma y you are taking 2 comma 2. Here the value will be 4 comma 4. So each and point we are getting right, corresponding image we are getting no, for each and every point we are getting the image. When to say this as magnification? Whenever this transformation you apply a times z. Okay, as it is the function what we define from this plane to this plane, same thing, function f. Okay, so this is it. So be clear in this idea. If I go for the problem, it will be very easy if you know these concepts. Okay, so we used to call this as magnification. Okay, so in the other way, I'll say one more thing I want to add here. Let me see the application of this conformal mapping. We apply this conformal mapping in fluid mechanics, electrostatistics, heat conduction, and so on. Wherever you have that physical situations can be mathematically formulated. Okay, conduction. Okay, so here we apply this conformal mapping. Now try to understand, realize we are applying that analytic function. You know that yes, of course, f of z is your analytic function, isn't it? One more thing I want to add now here. As I said, analytic function, I have to recall one thing. This f of z, you know, the function what you take in your hand, it should be a single valued function. No, already I told you it should be a single valued function. Only for that single valued function, this condition will satisfy. Otherwise, it's very difficult. So f of z should be a single valued function. So be thorough in that. The function what we take in our hand must be a single valued function. So I told you mapping, conformal mapping, isn't it? What do you mean by conformal mapping? And then the next definition I said magnification. Magnification means its transformation W equal to A times Z is said to be magnification. Okay, with this I'll go for the other definition. The next definition is what is it? Inversion. The next definition is inversion. What do you mean by inversion? Same thing. So just now I said no, Z plane, W plane, object, we are seeing the image of that object. The transformation, you know, here if you take your transformation, this W, you know, that function of Z, f of Z as 1 by Z. You used to call this as inversion. That's all. Very simple. So W equal to 1 by Z if you take, you used to call this as 1 by Z. Same thing. But here, one more thing I want to add here. Here, the transformation W equal to 1 by Z represents the inversion with respect to the unit circle. Modulus Z is equal to 1. So you have to note down this thing because the image, I mean, what they have given is under the circle only. Okay, I mean, the circle is in which plane? Z plane. Let us find the image of this circle. Image of this circle in which plane? W plane, using this transformation. I think during problems, I think I can explain same thing I used to do in the problems as well as in a simple way. I'll say what we are doing here. As I said, we are going to find the image of this circle in the W plane. Like how to find, just now previous case I have done no same thing. So take W as U plus IV. Okay, take W as U plus IV. Here I can take this as 1 by Z. Okay, so or otherwise you take Z as 1 divided by U plus IV. So this one is X plus IY. This one is, I think, take the conjugate. U minus IV divided by U square plus V square. I think, you know, X take the real part, Y take the imaginary part and substitute in your circle. Because they have told that in the Z plane you have a circle. I think by seeing this you are all clear. I mean radius 1, center 0 comma 0, because this is x plus iy, x square plus y square will get it is equal to 1. So 0 comma 0 will be your center and radius will be 1, isn't it? So using this equation you just solve this and let us find the image of the your object circle in the W plane. Okay, I think this information is enough for you. I'll go for the problem. Problem number one. So, problem number one. I'll tell you what is the purpose of this conformal mapping. I told you the application where we apply this conformal mapping, but in specifically when to use this conformal mapping. So, you have certain objects in which you want to deal, in which you want to learn something in the object, in which it is not very clear. Okay, so suppose if you have anything like that, you can apply our conformal mapping using transformation, whatever may be the transformation I taught you, like magnification, inverse, what is that, inversion, whatever may be the transformation, you apply it here and then find the image of your object. Say for example magnification, I think it's really useful because whatever may be the object you have in your z plane, w plane, if you see in your w plane, it will be little big or little bit bigger. So then you can identify the objects inside the graph or inside the circle, whatever you want. Okay, so this is an important transformation. Okay, problem number one, I'll go for the problem now. Find the image of the rectangular region. Find the image of the rectangular region in the z plane. In the z plane, bounded by the lines. So, okay, just listen what I say now because I can't write the question as a whole. Listen carefully. Find the image of a rectangular region in the z plane, bounded by the lines. So they themselves told what's your object or your or input or object in your z plane. It seems to be a rectangular shape, it seems. Okay, rectangular region only you are going to have. Okay, by the lines x0, y0, x equal to 2 and y equal to 1 under the transformation, because transformation I can't find my object, transformation should be there, w is equal to 2 times z. Fine. Yes. So here comes the thing. See here, z plane they have given you in terms of points. They have given you. You draw the graph. Let me see. Go for the transformation and find the image. Yes. Before going to the thing, I'll draw the graph as first so that it will be easy for me. See here. Actually, this is z plane, w plane. So here I have to define x-axis. This one should be y-axis. Similarly, this is your u-axis and this is your v axis. Fine. Now see here. So I can take this W as U plus IV, isn't it? Here 2x plus x plus IY, isn't it? So I into 2 times y. Come on. So U is equal to 2x. Come on. What is the other one? V is equal to 2y. Now come on. Step by step. When x equal to 0, what will be the value of U? So U0 when x0. When x equal to 2, what will be the value of U? 4. Similarly, what is the other thing? X0, Y0, X2 we have taken a Y0. Come on. What will be the value of V when Y0? Y0, V0. Similarly, what is the other one? When Y equal to 1, what is the value of V? 2. Very simple example I have given you. Let me do 2 or more problems in this. It will be interesting and easy to understand. Come on. So let me draw the graph in the Z plane as first because I got the point. See here. Look very carefully. I need V value. Here I need U value, isn't it? I mean, W plane, I need only U and V value. I got it. Now go for the Z plane. Let us draw the graph. So x0, y0 and x2, y2 it seems, no? So the graph will be like x0 means what? This axis, and x equal to what? You imagine the graph because I can't plot the points away 0, 1, 2, 3 like that. Which point they are asking here? X equal to 0 and x equal to 2. So draw the line like this, and then similarly y equal to 0 and 0 1 something like here. Okay, so I think I have drawn the graph. So this is your object. In which plane? Z plane. So what is the transformation I am applying for this? W is equal to 2z. F of z is 2z. Let us wait and watch what object we are going to see. I mean the image of this object in W plane. Let us wait and watch what image we are going to get. So V0, this is your U, yes. So U0, U4, okay, U0 means this one. U is equal to 4 means 1, 2, 3, 4 like this, okay. Yes, U4 I have drawn, and then one more thing left. Where is my V value? V0, V2. So V0 and V1, 2, somewhere here. Yeah, see. Okay, it appears to be more or less same only, isn't it? Yes. Little difference only is there, but more or less same. So this is nothing but image of the object. Okay. I think it's a simple problem only, so everyone can understand. I'll go for the other problem. Second problem. Second problem I'll choose is find the images of find the images of the infinite strips. Find the images of the infinite strips 1 by 4 less than y less than 1 by 2 under the transformation. So they have given you the strip streams. I think you all remember strip. Strip means I'll write it on the board. I think you may not know strip. You all recalling strip? Hmm? Yes. In finding area, we used to draw that strip. In the first unit strip. Same thing. So 1 by 4 less than y less than half. Under the transformation, W is equal to 1 by Z. I think it seems to be inversion, it seems. No? Yes, W is equal to 1 by Z. Okay, so this is your transformation mirror you have here. So let us find the image of this object. So object is this strip, isn't it? Let us find the image of this strip using this transformation. Come on, I'll go for the problem. So directly is here. Now, here Z is equal to what? 1 by W. That is x plus Iy. I'll do this and I'll draw the graph later. So x plus Iy, which will be equal to, I think directly you can tell. Now already I told you one model, 1 by u plus Iv, isn't it? 1 divided by, this is u plus Iv, isn't it? So I can write this as u minus Iv divided by u square plus v square. Now, what will be the value of x here? U by u square plus v square, comma. What is the value of y here? Minus v, this is I listen, I. So minus v by u square plus v square, isn't it? Now, when y is equal to 1 by 4, what we will get when y equal to 1 by 4? See here, I have taken, actually y, it is nothing but area between this and this. That's the meaning. Try to understand area between this and this. Now I have taken y as 1 by 4 and then I'll see the region between this and this. Okay. So first I'm taking y as 1 by 4. So what I'll get? So 1 by 4, which is equal to minus v by u square plus v square, isn't it? So which implies u square plus v square is equal to minus 4v. You agree? One more step. So which implies u square plus v square plus 4v equal to 0. One more thing I'm going to add here. Plus 4v plus 4 minus 4 equal to 0. Shall we? Shall we write like this? Actually, see here, this graph, I think I may know it's a strip. Draw the point, see here, y equal to 1 by 2, y equal to 1 by 4, you will get one strip. That's fine, everyone can understand, everyone may know. Now I'm going to find the image, corresponding image in the W plane I'm going to find. For that, I'm applying y equal to 1 by 4 and then I'm solving these things. I think you may know. I don't know how far you're understanding the thing. See here, 1 by 4 is equal to minus v by u square plus v square, and then I'm converting this and I'm converting plus 4 minus 4. Why I'm doing so? It appears to be a circle. Why not? Isn't it? One u square I have, one 4v I have. If I add 4, why can't I find my point, center and radius here? Only for that. Okay, so which implies, see, you look into it very carefully, u square plus, why can't I combine v square plus 4v plus 4 as v plus 2 the whole square, shall we, which is equal to 4, so which represents a circle, isn't it, which represents a circle of center and radius. What? Center 0 comma minus 2, so 0 comma minus 2, and center is this and radius is 4. Followed. Only for that I have taken. Similarly, when y is equal to, what is the other point they have given? 1 by 2. When y equal to 1 by 2, which implies same concept, 1 by 2, which is equal to, what is it? Y equal to 1 by 2 means minus v by u square plus v square, which implies u square plus v square What is it? Directly you tell plus 2v equal to 0, which implies u square plus v square plus 2v. Can you say which one to add here? Come on. 2v, 2 times v. So plus 1 minus 1 equal to 0. Obviously, can you tell me directly now? So u square plus v plus 1d whole square is equal to 1. So which represents a circle of center 0 comma minus 1 and radius is equal to 1. So you all remember the center and radius so that I can erase the value. You all remember? So first circle, what is center? See here, 0 comma minus 2 r equal to 4. Second circle, when 1 equal to y equal to 1 by 2 means I am getting a circle of 0 comma minus 1 radius 1. You remember? Now I'll draw the graph. I think of course problem is over. Only graph is pending. So I'll take the first half to explain. Look into it. So this is my Z plane. So in exam, I think this is enough. If you draw the graph, we are very much particular in graph. If you draw the graph, that's enough. Okay. If you represent the circle, if you know these things, represent the circle, that's enough. Now Z plane. So come on, Z plane. So this is x-axis and this is your y-axis. Now come on, Z plane. So y equal to something they said. What is it? Half. So 0.5 means something here. Can I draw? 1 by 4, which lies between 0.5 and this axis only, right? So y equal to what? What's the name? Name of this line is 1 by 4. Name of this line is 1 by 2. Come on, here lies a strip. I should not include this line. Between the two lines only I am including. That too I'll say clearly. Yes. Come on, let us find the object. I mean that image of this strip. See here, look into it. It appears to be like a rectangle shape, but image how I am getting is a circle. So this is the main thing here. Okay. So image for the first circle 0 comma minus 2. So this is 0, this is minus 1, this is minus 2. So minus 2, keeping this as center of radius how much? I told you to remember. What is it? Radius 4. Okay, a square. So radius should be 2 only, no? Actually 4. I can write this as 2 square, isn't it? So 2. So radius 2. Using this center of radius 2, I have to draw a circle. Yeah, I have drawn. Next, second circle, come on. When y equal to 1 by 2, what I am getting a circle? Center 0 comma minus 1. So minus 1. So center is here. Of radius how much? 1. So center is here. I have to draw a circle of radius 1. Yeah, drawn. Actually speaking, intersection of both the circles. Just like this. We have drawn the plotted the points. Now what will be the intersection of both the circles? So intersection will be this. That's all. So this is the image of your object.